Welcome back, everyone. Today, I'm going to show you how I built this 3D balanced drone model using the STM32F4 Discovery board and the ESP8266 module. As you can see, the results are actually, well, pretty impressive, especially considering we are solely using the LIS3DSH. That's the integrated accelerometer that comes built in, right on the STM32F4 Discovery board. Now, this project is going to be broken down into three main parts to help us build that interface you see on the screen. First, we have the configuration of the STM32F4 Discovery board. Second, the real-time data acquisition from the built-in accelerometer. And finally, putting it all together. So, let's dive right in. We're starting with STM32Cube IDE, where I'll walk you through exactly how to configure the board for data acquisition. Let's move over to the configuration. The first thing we're going to do is configure the 4 onboard LEDs. We'll be using these as visual indicators throughout our process. It's a simple but effective way to make sure our code is running exactly as expected. Next up, we need to configure UART2. This is crucial as it's how we'll be sending our data over to the ESP8266 module, right after we finish the data acquisition from the accelerometer. Think of this as the bridge between our sensor data and our wireless communication. Now, for the most important part, configuring SPI1. You might be wondering, why do we need the SPI protocol for this? Well, don't worry, I've got you covered. We're activating SPI because the onboard accelerometer is hardwired to the STM32 microcontroller using this exact protocol. If we take a quick look at the datasheet for the Discovery board, right here, you can see the MEMS sensor is connected directly to these specific pins. Because of that, we also need to configure pin PE3 as an output. We have to keep this pin high at all times to ensure the MEMS sensor stays active and ready to talk. As you can see here, we strictly need to configure PE3 as an output manually. Here's why. When we set SPI1 to full duplex master mode, the system automatically reserves the 3 standard pins for us. But it doesn't handle the chip select. And for the final step, we're going to activate FreeRTOS. We integrated FreeRTOS to move away from a simple super loop architecture. It allows us to manage multiple tasks independently, such as sensor data acquisition and UART communication. This makes our system much more modular. Now, I'm not going to bore you by typing out the entire main file line by line. Instead, I'll be sharing the complete main.c file along with the bare metal driver files for the accelerometer. These files are absolutely necessary to get the application running properly. Honestly, explaining the logic behind this bare metal implementation could take up an entire video on its own. So, if you want a deep dive into how I built this driver from scratch, talking directly to the hardware, leave a comment below and I'll make a dedicated video just for that. All right, after all that hard work, it's finally time to test the code on our Discovery board. Now, watch closely. As I move the board, you can see that the accelerometer is giving us the correct logic in real time. Just look at the LED indicators we set up earlier. They're reacting perfectly to the orientation, proving that our data acquisition and sensor logic are working exactly as planned. And that wraps up part 1 of our project, successfully acquiring data from the accelerometer. But we're just getting started. In part 2, we'll focus on the ESP8266. We're going to use it as a wireless bridge to receive our sensor data, which is essential for building our 3D visualization application. In the final phase, we'll be setting up a Flask server and importing a 3D drone model to bring it all together. This project is a fantastic way to practice everything from communication protocols and IoT to interface development. So, if you need any of the files we used today, don't be shy. Just let me know in the comments and I'll get them to you. Don't forget to subscribe and hit that notification bell because parts 2 and 3 are coming your way very soon. Thanks for watching, and I'll see you in the next video.